Disaster Resilience Symposium and Exhibition. It is my great honor to welcome to this morning session Professor Farina Ruzek, Head of the Department of Geography, Faculty of Arts, University of Colombo, our distinguished representatives from the United States Embassy, Colombo, whose generous support has made this project possible, our esteemed educated panelists, and our moderator for today's discussion, and to all our GeoAI fellows, both professional and students, as well morning. A very warm welcome to you all. Yesterday, we witnessed the remarkable breadth and depth of GeoAI research in action. Today, we turn our focus to the bigger conversation. What do all these maps actually mean for the decisions that shape life? We have a rich morning ahead. Let's begin. Our panel discussion today is titled From Map to Decision: How GeoAI is Transforming Disaster Resilience. We are privileged to have four outstanding panelists representing academia, government, and industry. Allow me to introduce them and invite them to take their seats at the panel. Our first panelist is a sociologist with over 26 years of teaching and research experience at the University of Colombo. Professor Nishara Fernando specializes in disaster studies, applied social research methodologies, and urban sociology. His research focuses on displacement, relocation, social vulnerability, and community engagement for urban transformation in the global south. He has served as head of the Department of Sociology and as the director of the Social Policy Analysis and Research Center. He holds a PhD from the University of Bonn, Germany, and was honored with the President's Award for Scientific Research in 2018. He has led projects funded by the World Bank, the Bill and Melinda Gates Foundation, Erasmus Plus, and the Swiss National Science Foundation, among others. Please welcome Professor Nishara Fernando. Our second panelist is a geospatial and disaster risk specialist from one of Sri Lanka's foremost research institutes. Dr. Danushka Jayatilaka is a senior scientist at the National Building Research Institute of Sri Lanka. He holds a PhD in civil engineering from the University of Tokyo, an MSc by Research in Civil Engineering from the University of Moratuwa, and a BSc Honours in Town and Country Planning, also from Moratuwa. His specializations include geospatial databases, drone-based mapping, nature-based landslide risk reduction, rainfall-induced landslide assessment, and GIS-based spatial analysis for disaster resilience. Please welcome Dr. Danushka Jayatilaka. Our third panelist brings nearly 20 years of expertise in meteorology and climate science. Ms. Preetika Madhavi Jayakodi is currently serving as the Director of the Climate Change Studies, Research and Seasonal Weather Prediction at the Department of Meteorology, Sri Lanka. She previously served as Deputy Director at the National Meteorological Center. She holds an MSc in Meteorology from the University of Philippines with a research focus on the influence of La Nina on Sri Lanka's rainfall pattern. Since 2019, she has been actively engaged with the IPCC and the Asia Pacific Network for Global Change Research. Please welcome Ms. Preetika Madhavi Jayakodi. Our fourth panelist bridges cutting-edge geospatial technology with real-world applications across both government and industry. Mr. Supun Sirivardhana is the General Manager and CEO of GIS Solutions, the sole authorized distributor in Sri Lanka for Esri, the world's leading GIS software company. With over 15 years of experience, he also serves as a visiting lecturer for GIS programs at the Universities of Colombo, Peradeniya, Sri Jayawardhanapura, and Kalaniya. He is the only Sri Lankan holder of two Esri software certifications and has led many of Sri Lanka's pioneer national level cloud GIS implementations since 2014. Please welcome Mr. Supun Sirivardhana. With our four panelists now seated, allow me to introduce the person who will guide this morning's conversation. Dr. Tissara Geethika Pereira is a senior lecturer in human geography at the Department of Geography, University of Colombo. He holds a Bachelor of Arts Special in Geography from University of Colombo, an MSc in Environmental Management from the University of Sri Jayawardhanapura, and a PhD in Geography from the University of Huddersfield, United Kingdom, where he was awarded the prestigious AHEAD Scholarship in 2020. Dr. Tissara's research spans medical geography, spatial epidemiology, and disaster management. He has authored multiple Web of Science indexed articles and presented over 30 scientific communications internationally. He has contributed as a researcher in the EU-funded BRITA and SECRA project. Please welcome our moderator, Dr. Tissara Geethika Pereira. Sir, we are delighted to place this conversation in your capable hands. The floor is yours.
Again, very good morning, everyone. Thank you, Lochana, for that introductions, and welcome you all, and thank you for being here. So let me start with our panel discussion today. So as the moderator, so we have arranged a steamed panel for this panel discussion. So we are discussing about, so as you saw in our digital screens, about GeoAI and disaster resilience. Now, so we gathered today what I believe is a genuinely important conversation, because in one aspect, we are considering about the AI platforms, and also on the other hand, we are discussing about another most pressing challenges in the current world, the disasters. So the protecting lives and livelihoods in the face of increasing vulnerabilities is a main concern in this era. So this session is titled as From Maps to Decisions, How GeoAI is Transforming Disaster Resilience. So with maps, like pixel on a map, can decide whether this population can be affected or can be preventive or can be saved from a disaster. So this specific topic, we have assembled an extraordinary panel. On one hand, we have Professor Nishara Pranandu, a sociologist, and the sociologist lens will be discussed through the disaster governance aspect. And on the other hand, representing the National Building Research Institute, we have Dr. Dhanushka Jayatilaka, and he is a landslide and national building research expert and a senior scientist. So he will bring the first-hand operational experience on landslides. And from the other hand, Ms. Preetika Jayakodi represents Sri Lanka's Department of Meteorology. So the backbone of our national early warning infrastructure. And again, we have Mr. Sukun Sirivardana, brings the private sector perspective. So, so let's move forward with our panel and with our question. So let's start with our disaster risk governance and also about the social dimension. So perhaps it's better to start with the people. Okay, so we have our sociologist, Professor Nishara Fernando. Professor Nishara, now GeoAI promises extraordinary things like real-time risk mapping, flood modeling, and also satellite-driven landslide detection. But we know when it comes to the practical scenario, sometimes there are some blind spots of this GeoAI as well. And at the end of the day, we are planning for the sake of the people. So how we can save these people. So you have spent years of examining the relationship between these systems of power and also system of this risk. Now my question is, Professor Nishara, now this most of these disaster resilience frameworks have long been criticized for overlooking these social inequalities. Now, how does this geo AI risk information or these community disparities are absent from this data collection, and what sociological approaches can be ensured for more equitable outcomes?
Thank you, Dr. Tisara. I think good morning to all of you. First of all, I would like to thank Tisara and the organizing committee for inviting me. And you posed a very broad question, Tisara, and I have only 5 minutes to answer. So therefore, let me try and answer to your question. I think your question, it has two sub questions. The first sub question is, how GeoAI can reinforce disparity, which is also important point to discuss. And then what type of sociological, I would say, approach or approaches that we could think about to equity, improve equity. So with regard to first question, how GeoAI can reinforce disparity, I would like to mention 3 points here. The first point is, one could argue GeoAI can reproduce inequality when it is built from unevenly produced data and then used to automate decisions without affected residents in the room. So as you have already stated, if we don't consult, if we don't have a kind of a people-centered, community-based approach, so this can happen. Then the second point I would like to mention here with regard to the first question, ethics work on Geo AI. For instance, one could argue that geoinformation technologies can not empower, disempower individuals and groups, especially when it comes to vulnerable groups. At the time, critical GIS reminds us that mapping is never neutral. It is tied to power relations and social justice. So sometimes, as we know, we normally don't like to include illiterate people because we have to spend a lot of time with them and we are working under time pressure. So therefore, right, so we purposively exclude some groups, right? They could be marginalized, but most wanted people that we should include. And the third point is research on disaster resilience explicitly recommend community participation in pre-disaster processes such as damage assessments, litigation, payments, and housing, because otherwise people most affected are least able to shape the response. So I think these 3 points are important when it comes to how GeoAI can reinforce disparity. Then also we have to now I would like to just mention how we could include, other than excluding, include them into the action, or in other words, sociological approaches which we can see to improve equity. I think there are 3 points which I would like to stress here. The first point is intersectionality. So intersectionality is the first key approach, because vulnerability is produced at the intersection of race, class, gender, age, ethnicity, sector, caste, and livelihoods, but not just we can't just assess the vulnerability only exploring the exposure factor, but also that is the external side of vulnerability, but we also need to consider the internal side of vulnerability as well. So in that case, there are inherent vulnerabilities, so we also need to think about this. So this intersectionality is very vital. As I said before, adaptation work shows that this framing improves both diagnosis and intervention design. The second point which I would like to mention here is that meaningful community engagement, which is the second, how we should engage community into the action. So community-based approaches are important, and it has to include early involvement, shared decision making, trusted spaces for input. And because I think I have taken more time, so the conclusion is a realist view found that participation only becomes meaningful when organizations adapt their processes so that citizens can actually influence governance, not merely comment on it. So that's also very important. You know, why we ask people to participate, just to say that they have participated, or whether we have whether we have really considered their points in order to change the system of a governance approach. So I think the last point is, so this also lead to the second point which I mentioned. Participatory research for environmental justice is the third point. So especially when the goal is structural change rather than token consultation, I think participatory justice is very, very vital in this regard. So I have some other points, but depending on the time, let us discuss that later. Thank you, Tisaba.
Thank you, Professor Fernando. So first of all, I think you have given us a compass for the rest of this conversation. And from the other hand, so I understand is that the human dimension is not optional, but it is the mandate. And then, so let's move to the geological perspective with Dr. Danushka. Now, Danushka, now you operate in real world conditions actually. So you know the scenarios. And then, so with limited sensor networks and also institutional pressure, and also there were some missing alerts, missing people, and sometimes it's a tragedy, right? Now, so as I know, the National Building Research Organization, as the focal point of the landslides, monitors some of Sri Lanka's most complex terrains, right? So in your operational experiences, how effectively do these current Geo-AI driven landslide susceptibility models perform against the ground truth observations? And what are the most critical gaps that still need to be bridged? Dr. Jatilaka?
Yeah, thank you for your question. Actually, so we, the National Building Research Institute, as we correctly mentioned, we are dealing on the landslide. Basically, not only the landslide, the geohazards. So, I mean, the most common is the landslide, but the subsidences and some issues with the building construction, and so many complex issues we are handling. But the most common and most frequently considering issue is the landslide. So our landslide, we started to work with the landslide somewhere 40 years ago, something like that. So by that time, actually, there were no signs of even the AI or the sophisticated software platforms or those things. So from that onwards, we have transformed into the the cutting edge AI, machine learning, and this GeoAI techniques by the time. So, but still, as you correctly mentioned, we are facing huge challenges when the outputs translated into the ground reality. So we one of the key tool we are using for the analyzing or the working with the monitoring the terrain conditions are the landslide hazard zonation map. It's a kind of susceptibility map. We use 7 factor maps, something like land use, landform, hydrology, geology, such kind of maps, and then we use some GIS-based model to produce our final map. So from 1980s up to the 2000, so this recent years, we have tried with some kind of models like the random forest models and something like that to predict the susceptibility. When we tried with the susceptibility maps, they showed some high accuracy levels when we are transformed them into the ground level, but in regional scale. Right? We can work with the maps, we can work with the models in the regional scale, but when we try to convert them into the local level, very local, very specific level, it's very difficult to work with this kind of model. So in NBRI, we use two kind of landside risk assessment. One is this maps using these GeoAI models, remote sensing, GIS, and all those things. But we use them as a decision-making tool for the regional scale, not for the local scale. So when we receive some kind of location-specific analysis, we deploy our teams to assess that the particular location in person. Then we issue different kind of report. Mostly the decision is based on the macro level or the regional level analysis, but local level decision is very difficult to take from this model. So because you know that the terrains are very complex, so there are very huge differences from place to place. And another point is, so the very recently, just after the Ditwa, we all know that the huge disaster, especially landslide events occurred. So just after the Ditwa, we faced a huge challenge to restore the daily life of the people within very short time of period. You know that the almost all most of the road networks were affected, and they become they become actually unusable. So they were unable to pass certain locations with where the landslide or the debris flows affected. So we were supposed to restore those locations as soon as possible. So in order to do that, we need to identify, we need to understand the situation after the events. So then we deploy some UAVs with LiDAR sensing. Then we deployed the kind of rapid program for the hotspot. Then we we implement two type of restoration things. The first one is the temporary restoration. We temporarily open the roads. Actually, most of the road even today is temporarily open. Not the permanent solution have not been implemented yet. So then, in order to do that temporary the restoration methods, we deploy this UAV based LiDAR. Actually, those integrated with the AI models and the cutting edge softwares, we were able to identify how where the fails happen, where the soil have been accumulated, then how we need to reshape these things, and where we need to retain, and how we have to divert the water networks and other things. Then we do those things, and we temporarily open the roads within about 1 month, maximum 2 months. Almost all the isolated areas we were able to open for the public. Then next is to implement the permanent solutions for those the affected locations. Actually, permanent solutions have not been completed yet, so they are on the way. But in order to design those permanent countermeasures, we have to identify, we have to do some analysis, cross-sectional analysis, and we need to do some the slope stability analysis, basically, where we use the geotechnical engineering models and those things explicitly. So for those things, we need the base layers, base maps. We know that conventionally we do by this the ground surveys, but it takes time. And most important is it's not accessible. After the failures happen, the slopes and the upper slope, even the down slope, it's unable to access. So for those things, we still use the LiDAR and the course the positioning networks and all those things. Then we collected the data. It's about 200 locations all over the country along the railroads and main roads and the schools and hospitals and with this critical infrastructure. So now we are at the moment also we are working on this designing these countermeasures and the constructing those on the ground, even not yet completed. So those things, those are the some of the key things we are using this GeoAI and the modern cutting edge technologies for this the monitoring the terrains. And sometimes we use this like the SAR technologies to change direction, identify the change over the time series analysis, something like that. And the issues, the challenges are immense actually. So the first thing is as I mentioned, the transform them into the ground. So the ground way, the minor changes, complex terrain, so it's unable to capture by the models those things. So then we use our human capacities to interpolate those into the local level.
Thank you, Dr. Danushka. Now, so as I understand, so the gap between these models output and also with the real world, I think it's still existing. So as I understand, and also I think that so these things has to be discussed in depth maybe in the next round. So next, I would like to move with the Department of Meteorology. Now, Ms. Preetika, so most of these disasters, every landslide triggered by these saturated slopes, every coastal floods driven by storm surge begins in that atmosphere. And now the Department of Meteorology is, in a very real sense, the nation's first line of warning. The accuracy of rainfall forecasting determine whether a family has 12 hours to evacuate or 12 minutes. So in that sense, Ms. Preetika, now I would like to start with the landscape of what we are working with. So here, so what type of meteorological and geospatial data currently used for this weather forecasting? And also, as the Department of Meteorology, how can AI or maybe GeoAI improve the accuracy and timeliness of this weather forecasting and also early warning systems?
Thank you. I think we are dealing with the different aspects of previous speakers because we are dealing with atmosphere. It is very challengeable task. So even one change in the ocean, it's also influenced to our weather patterns. So it is very critical task. So when I concern about the observation, actually Department of Meteorology as well as our region global, they are taking observations every 3 hourly. Atmospheric data, wind speed, temperature, rainfall, that kind of data. So the focus about our forecasting, we need actual observation because we need to identify and understand what is the real situation in the atmosphere. So collecting data during this type of bad weather period, especially for the cyclone, low pressure areas developing near the country, we have to get frequent data, hourly data. So this is big data. After the observation data, we analyze regional data, global data. This is current observation data, and also we use satellite data, especially for the atmospheric condition and also satellite picture, also to monitor the winds over the sea areas. So these two kind of data we analyze different ways, and also we, after the analysis all the things, we use numerical weather predictions. Those are our prediction data. So currently we are using European model we call ECMWF data. This is very most accurate data in the world. So using those three types of data, we are issuing weather forecast. But currently actually we don't directly use GeoAI, but we use IBL platform. During that platform, we can overlay all the data, wind data, RH, and also satellite data. We can overlay maps within that platform. But I think because we are dealing with very big data set, so we can use GeoAI in the future. Maybe we can get the support of University of Colombo. We had also collaborate work during last 1 year. So we need to improve the accuracy, especially for during this kind of bad weather period. The time is very important. We need to analyze very frequent data and also within the limited time period. So we can use that one. Also, it is very important to identify vulnerable areas. Normally, department issues rainfall forecast and also advisories. So we can use, if it is some areas, the people ask so many questions. We are doing public weather service as well. So different calls comes to the department. They are asking, are they vulnerable? So we need to get the idea of that locations. So I hope using GeoAI, we can improve accuracy, also timeliness in our forecast. Thank you.
Right. Thank you, Ms. Pritika. And you highlighted a very important pattern about this collaboration, right? Now, so for the collaboration, I feel that even for the government sector, we need the support of the private sector. But the problem is it's often overlooked. Now, Mr. Supun representing that private sector, we often overlooked. Now, Mr. Supun, the most sophisticated GeoAI platforms, even the GIS or maybe other software, well, the problem is, will it be useful if a disaster risk officer or the office can't afford the subscription, right? And also, if they can't train their staff using that software, it's again a critical issue, right? And the problem is now the private sector is increasingly developing these powerful GIS and also GeoAI platform. So in your experience, how can these commercial solutions be structured or maybe priced to ensure that they are genuinely accessible and also that can be used for national disaster management agencies rather than remaining out of reach? So what are the ideas, Mr. Sopon?
Yeah, actually, thank you very much for having this panel. I think it's a timely, important discussion. So let me come to the first question, the commercial GIS, why the commercial GIS is in the world. So the reason is actually the lot of investments. So if you take Environmental System Research Institute, S3, so they have over 55 years of experience of developing this technology. So there's an investment. Every year they invest their revenue, 30% of their revenue back into the software development. That's why we are getting GeoAI, these geoanalytics, and various different types of software platforms. And R&D is going on. So that's why imagery data. Sometimes some places the imagery data downloaded, but other agencies loaded, but other agencies maybe not having that access or not aware about that imagery accessibility. So even software is there, but the timely important images, right? We can get the images after a while, but then the things has happened. So what I have seen, um, software side, we can always contribute, right? But from the data side, we have to develop maybe interagency, some policies, maybe synergy. So there are so many things we can do. And also, I would like to give another example during the COVID situation. I think we again supported with software. Dr. Novil was the key person, and developing proper practical applications. So you can educate people with training and those things, but the practical applications comes from the expertise knowledge. I think the Ministry of Health is expertise knowledge. He developed 3-color map, right? That was really useful at that time. Red color, green color, yellow color. 3 colors. Very simple application, but so powerful. Very powerful for decision making. So software can be given, or that is not an issue actually at the moment. I think the data and the practical applications, you can have that in the proper situation, in the disaster situation. Yes, then we can have very powerful applications. Even a paper map can do a lot of things, right? Okay.
Thank you, Mr. Sapon. Now, I think you highlighted very important few facts, including the decision making, actually. Not actually about the commercialization of a particular software, but how we can use it for our decisions is the crucial factor. So, based on that, sometimes I feel that the best susceptibility model is only useful if it is helpful for the people to evacuate or get the support, right? And on the other hand, so sometimes to evacuate a village at midnight, will it be feasible? Whether to close a road is enough for that, or maybe sometimes you can say whether to sound a siren, right? So all these decisions can be intersect with the technology, right? And then it also we have to keep in mind about the trust and also the institutional capacities. Now, Dr. Danushka, so real-time landslide early warning requires both high-resolution sensor data and also rapid AI interferences as well. And on the other hand, we know landslide is a rapid onset disaster, not similar to floods or maybe like the droughts, right? So in that sense, what technical and institutional barriers have you encountered in translating these GeoAI outputs into actionable alerts for these risk communities, and how these issues can be addressed?
Yeah, very good question. So how this bridging GeoAI outputs into actionable community warning, something like that, right? So we are also having this issue in our mind. So the technology have been evolved so much, and so we have this AI, machine learning, and we have the satellite imagery softwares, but still we are reporting number of deaths after a catastrophic event. So that's a kind of issue in our minds also. So so in order to issue the landslide early warnings, we use two kind of information. First, and the important information from the meteorological department, as Ms. Pritika mentioned. So we observe the 10 days forecast. Right? 15 days forecast. 15 days forecast. Yeah, the yesterday rain also predicted by the meteorological department by last Friday, if I correct. So we saw that the 14th there will be kind of severe rainfall within the country. So that is the first data we use to trigger the landslide early warning mechanism. But still, this the landslide, as I explained earlier, so there are vast local differences in the behavior of the slopes or the ground or the soil. So in order to closely monitor the ground behaviors, NBRI, we have established automated rain gauge system, IoT sensor system for the rain gauge measurement now we have about 500 real-time rain gauges all over the landslide prone areas. Landslide prone areas means we are monitoring 14 districts. In area wise, it's about 20,000 square kilometers, roughly about one third of the country's the size, and about 30% of the population living in that area. So we are having about 400 to 500 automated rain gauges. So when we talk about the density, it's one gauge for roughly about 50 square kilometers, something like that. But still, the density of the system is not sufficient, because the 50 square kilometer there are local differences, and still the lead time is the issue. So when we observe the rainfall and then we issue the warning, and this issue the sensing the rainfall and issuing the warning is not sufficient to actionable warnings, because the communities receiving the warning should have clear understanding about what this warning and how they have to react and what's their risk level. For those things, actually this is not a technical issue. This is I'm talking the socio-technological issue, something like that. So the technical decision should transform into the community understanding. So for that one, still we are doing something called the community-based landslide risk management. So we have identified the people who are living at risk. So we have grouped them, and then so we are doing kind of awareness program, community mobilizing programs in local level with those communities, and we reach to the schools. We have established school the risk volunteers, risk frontiers, something like the junior scientist program, something like that. So then we educate them on these landslides, how that happen, how they can identify landslide pre-signs, and if a landslide warning issue, what should be they do needs to do, and if they are to evacuate, where to evacuate, something like that. So whatever the most recent the experience, so we issue landslide early warning frequently, sometimes twice a day, but that warning is still regional level. We are not so what we call that the impact based forecasting we are not doing. Impact based means, so we issue the warning to at-risk people directly to them. So our plan is to go for that impact based warning. So we are having under this institutional capacity arrangement, I will explain that one. So we are implementing certain things, but still we are issuing regional warning. So that means the whole region is not prone to landslide, but there are certain hotspots. So then the responsibility of that community is to understand the warning and act on that one. For that one, the community mobilization is essential to understand that the technical outputs and the outputs derived from the GeoAI or AI or these models. And next thing is the institutional arrangement. So in our disaster management setup, so we have very unique arrangement. So the meteorological department or the NBRO or the irrigation department take the technical decision on this the disasters, but the disaster management center is the sole agency responsible for the dissemination and that part. So we issue the we generate the warning and issue to the disaster management center. So they disseminate the warning through this their channels to the local level. But actually that the dissemination into local level is a challenge for any institution, what DMC or the NBRO. It's very difficult to send that message to the local level. Whatever if you can remember, there were some set of landslide events in 2017. So in that event series also, when we do some kind of back analysis, the warning message not reach to the 50% of the population at the correct time. So there's an issue with the sending that message into the last mile. But now those things have been bit improved with this the modern the communication enhancements, and still so as a hydrometeorological disaster management institution, DMC, Met Department, Irrigation, and NBRI, we are working on one focused project under World Bank funding to enhance this decision making process with through this modern AI and the modern cutting edge technologies. So we are developing kind of different systems within our agencies, and the DMC is doing one decision support system. So we take decision and we push them into the DMC system, then they disseminate that into the community level, and those the systems will be implemented and will be open to the public, so that they can get that warning directed to their the mobile devices. But still the literacy and the accessibility to those things, when we are going to these far the state communities or something like that, so their awareness and literacy is quite questionable. How hard we implement use the technology, the how we can send that technology, how we can send that message to that at-risk community still is a issue. But we are keep trying to enhance the capacities of the people.
Right. Dr. Danushka, thank you very much for that honest answer, actually, because we know the critical gaps that they are facing as an institute. And also, that's the conversation we expect from this kind of a panel, actually. And also, it's not actually about the failure of the technology. And also, it reminds us that the technologies alone is never enough. That's the idea. And then, with that, I would like to move with our Professor Nishara Fernando's perspective. Now, I would further push it this way. So we increasingly see these kind of AI tools can map flooded roads, and also we can count damaged rooftops from satellite images, and also at the same time we can estimate the population displaced. We can take the count. So these are, from one aspect, extraordinary capabilities. And also, but there's a question lies beneath these pixels, actually, beneath these images. Why I'm saying that? Because there are some griefs, cultural memories, and also informal social networks that has been damaged. And also, those things that pull them apart from one person to one family to another is something not captured directly from these GeoAI tools, actually. And so quantifying these effects or understanding the physical hazard capturing these processes sometimes misses this lived experience and also this cultural context. So my question is, Professor Nisharan, now, so how, with all these issues about these lived experiences, cultural contexts, so that shapes the community's actual capacities, and how we can consider those aspects when we are implementing these GeoAI tools?
Yeah. Thank you, Dr. Tisara. I think Dr. Danushka also brought in a very important point here, that how we can identify hotspots, vulnerable, I would say, communities. But now passing the message to the exact community is an issue, right? So now that's one. And also when we try to relate it to your question, sometimes people might neglect the warning, right? And we have seen they just neglect it for whatever reason. Sometimes the father take the decision, right? No, this is not going to happen, you have to stay. So I think these points can be discussed under, I would say, the broad term of culture and subcultures. We have culture, we have Sri Lankan culture, and also we have different subcultures. So I think now, from a sociological perspective, as you have correctly said, GeoAI should stop treating resilience as a property of terrain and infrastructure alone and start treating it as a relationship between assets, institutions. You also brought in the concept of culture, social ties, and unequal access to resources. So, further to this, my explanation or to your answer to your question, social science reviews shows that vulnerability is shaped by socio-economic, historical, and political factors, with culture, knowledge, governance, and resources access, all affecting who is actually exposed, who can respond, and who can recover. So now the point is, as I already mentioned before, now what GeoAI should capture beyond assets counts, which is very important. What they should capture. I think they should capture, you already brought in that word, lived experience, not just exposure. And that means incorporating place attachment, which is a big issue when it comes to displacement and relocation. Place attachment, which is a big issue now, right? And symbolic meanings, like for example, right, like this is our common graveyard where they should bury us. We should not move into a new place, right? Vacating the place. So those kind of symbolic attachments, trust in authorities, local coping practices, and the ways people interpret risk in everyday life. Like for example, some people take the risk, they are living with the risk, right? So that we have to capture. Then, because these can shape preparedness and support for adaptation, even when physical assets levels are similar. Another important point is it should treat the community as a socially constructed rather than fixed spatial container. So it's keep on changing, transforming, right? So that we have to consider, right? And also because people respond, they cope short term, long term, right? So that we have to accept. uh, uh, we also need to consider, right? Disaster resilience measures change depending on whether community is understood as place based, interaction based, or community based, community of practice. So GeoAI models need to encode social networks, caregiving ties, mutual aid, and institutional roles, not just map who lives near a floodplain, right? So it should, as I said before, it should include participatory and qualitative data streams, which are also important. So then one can argue, uh, in order to create a stronger GeoAI pipeline would combine hazard layers with social vulnerability indicators, local knowledge and culturally grounded risk categories from community mapping and oral histories, measures of trust, governance, and perceived fairness, and also it can include social capital, mutual aid. So then, in order to conclude, so what should be the sociological shift which we should consider? The sociological shift should be, the key shift is from where is the hazard to who can actually act, adapt, and recover in this place under these social conditions. So this is this should be I would say the sociological shift. There, that means GeoAI should be co-produced with communities, use mixed methods, and be explicit about power, which I already addressed in the first mentioned in the first when I try to answer the first question, exclusion and cultural meaning, it will keep mistaking mapped exposure for lived vulnerability. So I think this is the short answer. Thank you.
Thank you, Professor Fernando. Now, so on one hand, it's feel like from quantification to qualitative data. So we need some kind of a shift. So I think as the Department of Meteorology, that shift has been discussed and also it has been implemented from the department. Now, Ms. Preetika, now in the early days, from the meteorologists, we are just asking about the forecasting, what will happen tomorrow. But now I think there are so many things asking from the Department of Meteorology. So they are asking about the infrastructure and also the agriculture and who are the vulnerable communities. So many things to discuss or consider now. Now, with the support of this kind of a technique like GeoAI, how can these GeoAI based technologies be implemented if needed? How it will be implemented within the Department of Meteorology to strengthen this early warning system? And also, Professor Nishara highlighted this impact based forecasting. And also, we can think about decision making process, how it can be implemented in the department.
Yes, I think it's very important question. I'll start with the impact-based forecasting. Actually, right now we are doing impact-based forecasting just for rainfall, strong winds, and some rough seas, that kind of areas. Because in Sri Lanka, we have different kind of responsibilities as an agency. We are responsible for the rainfall or early warning mechanism, and we are responsible for the landslide warning. And the irrigation department is responsible for flood warning. So with that sense, Department of Meteorology is working for the early warning aspects for the rainfall especially, and also lightning, some kind of data. So we issue different alert or warning systems by using color code. This is identification kind of risk actually. The red color means it's high risk. So I think nowadays some people know the situation, but some community cannot understand. Still, we have gap here, and also we issue threat level for the whole district. I think there's a gap because beyond that we cannot go. We don't have that kind of data, and also the limitation of the predictability. So I think we are actually working for the heavy rainfall measurements. So when we consider about heavy rainfall, now it's more than 100 millimeter rainfall. But sometimes some areas, they receive more than 50 millimeter rainfall, it's flood condition. So we need to identify threshold values. So at that situation, we have to work with, collaborate landslide areas and also the NBRI irrigation department to identify threshold values. Then we can focus what professor mentioned about that. Also, I last year I participate workshop in Korea. They have good data set, especially for the disaster purpose. They know how in that countries the parents stay alone with their old age. So they have good database with the old people where they are staying, and they know how evacuate. First, their priority list with that area. So all the maps are with them, disaster situations. So it is very important. But in our case, we don't have that kind of data, so it's very much needed. And also the land use, it is also different. And also urban areas, sometimes we have a flash flood, not only the river basin areas. So this is deeply we need to understand and do research. I think geotechnology is much more important during that events. And also in Department of Meteorology, we issue drought monitoring bulletin. I think Dr. Tisarano, he works with that. We use SPI index. So in this case, we analyze last month rainfall data and also how it's compared with the climatological data. And we calculate standard precipitation index up to 12 months. So this is one kind of indication for agriculture and the deep groundwater level we can measure using that SPI index. So with that, actually, if we have some land use data and what cultivation data or something, we can get the idea. So which area facing to lack of water, something like that kind of decision we can uh, do with that analysis. And also, I think we need more collaboration actually, because just rainfall warning not enough. So we have to identify heavy rainfall areas and the landslide area. So final output goes to the community. So they receive one rainfall warning and also landslide warning, the different sectors. So if we can give them one risk level or something, it is very important. And also we can use GeoAI technology for that. With that sense, it's very much supported to decision making, especially for the emergency response. So finally, output should come to the community, save life and properties. So hope we can use GeoAI and collaboration work to save the lives. Thank you.
Thank you, Ms. Pritika. I think it's a very crucial factor you highlight about this institution collaboration. But I think this is a good platform and a good stage where NBRI and also Med Department and also representing the private sector, Mr. Supun also there. So I think the collaboration is here. Now, Mr. Supun, we have to think about this public-private data partnerships. So the sophisticated technology is with you, the softwares are handled by you, and you are commercialization, and the vendors are in front of you, right? How these public-private data partnerships can play a critical role when building this kind of long-term national resilience capacity. What are your thoughts on that?
Yeah, absolutely. So we can always share knowledge, training, software, but said you earlier, the critical part is with the data. So when there's a flood, someone is sometimes people asking us, you have the best software, can you uh, give us an answer where it is flooding? So we are saying no, that's related with another department. They are having the data, the domain expertise is there. So always GIS is challenge, right? Because of that. So that partnership is very important. And also we need to understand several aspects of this. One aspect is technology and these software things. The other aspect is the domain expertise with these agencies, Med Department, NDRI, irrigation, they have their own domain expertise. Then the other aspect is the general public and the social understanding on this. Sometimes when people say about GS, they think it can do everything. No, right? So even GeoAI is now, it's a very fancy word. All are saying about GeoAI. GeoAI is part of GIS, right? So it's an emerging trend and there is so many R&D going in the world. So with the R&D, it will further develop, right? So at the moment, there's a level we have to learn it and maybe applying the practical aspect with these domain experts, right? Then we'll realize certain issues and certain level of applications according to the practical realities in Sri Lanka, right? Sometimes certain models can be very useful in the certain regions. In these GeoAI models, there's a term saying applicable geographies, right? If you say building extraction, there's a pre-trained model. It is saying it is applicable for US and Canada region because of their shape of the roof and the clearness of the images and everything, right? So in Sri Lanka, we have to do certain calibrations. So this public-private partnership very important. It should start from the R&D level and the practical aspect as well, right? So based on that, we have to have certain applications useful for them, right? We have so many technologies, sometimes it is may not useful for all the applications in Sri Lanka. So based on that, we have to prioritize and take certain applications and take it forward. So for example, I'll take an example for one particular application we have, that form-centric data collection tool called Survey 123. So we initially introduced this during a disaster period in 2016. Then the requirement was to have three answers from the community. One is what they need, whether they need cooked food or dry food or water. So the problem was we started, the form was created within few hours. Then to give that form to the public, there's an approval process, right? So we can't just put it from the private sector in, because there is an approval process, and then only they publish the form. During that period, 1 day period, all devices died, right? You know, these three areas, you don't get the electricity and things. So if we had a better mechanism, like, you know, maybe form was created by 1 hour, next hour with the approval process, it is published. So for that also, we got like 4-5 requests from the field level. That time, this mobile GIS is not very much in the country. One request was real one for asking food from a school, right? So they supported them. So we were really happy about that. But we were so worried about the delay, 1 day delay, right? So this partnership, I think it should go with proper understanding. Sometimes these policies, sometimes the procedures take time, right? So if we can resolve them together, right, then I think we can do better service. Otherwise, we will have the software with us, data will reside on some other places, and the experts are there, but still we are suffering from the disasters, right? So I think this is a good platform for the collaboration, and we should take this discussion forward in the future also.
Thank you, Mr. Supon. I think you highlighted a few critical factors regarding the collaboration. So today we covered the enormous ground actually. So from the sociology to vulnerability, and also then physics of log failures, and also we discuss about the rainfall forecasting and the critical gaps. So what has emerged, as I understand, so GeoAI is not the silver bullet actually, right? But if it is in the right hand, with the right people, with the right intention, we can do some magic. So that's the idea behind. So in that sense, one last closing questions to all of you regarding this Geo AI and how we can implement or how we can utilize this kind of a technique in real world scenarios, right? So can you name one thing that will be helpful to implement these things in the ground level as a tool that emerged in the modern technologies? Professor Fernandez?
I would be very quick. I think my answer is the single most urgent systematic change is community co-governance of GeoAI. Community co-governance of GeoAI, meaning affected residents and local organizations must have real decision-making powers over what gets mapped, which data are used, how outputs are interpreted, and how outputs are interpreted, uh, and when a system is allowed to shape policy. So this is the change most likely to turn GeoAI from a technical forecasting tool into a resilience tool that actually works for vulnerable communities. So that should be my intervention. Thank you.
Thank you, Professor. So very simply, so human choices and human values are very critical in those implementation of GeoAI tools. Yes. Dr. Jayatilaka?
Yes. Not the one thing, I will talk about two things, right? One is at the moment, even this the AI, Geo AI or the GeoAI, they're having immense capacities, but the issue is with the applications, how we apply them into the real world scenarios. So one recent example from my experience was, so there was a fire at Karadiana waste dumping site 3 weeks back, I think. But the fire is at the not in the surface, but inside the garbage dump, so no one can see the flames, only the smoke. So at the process of the, the diminishing the fire, firefighting, so it was very difficult to identify where the locations fire exist. So then we intervene on that one with our thermal sensing drones. Then we did some thermal anomaly analysis over the waste dumping site. Then we identified some hotspot. Then we do the time series analysis with every other day for 1 week. Then we given our data at the same day to the waste management authority. Then they treated to that the hotspot. So we were able to successfully subside the fire within about 2 or 3 days, something like that. So the applications are the important. So there are sufficient capacities with the technology, but the application is the most important thing at the right time, at the right place. Next one is as I explained earlier, as the Professor Nishar also mentioned, the community empowerment. How the community understand these applications of the GeoAI, or how they interpret the outputs. So that the using of this AI or GeoAI, or we say the augmented reality, or the the AR or VR visual. So those things, it's very very complex, right? So those things need some kind of expertise knowledge. So we thought as NBRO, yes, but everyone in the community, everyone, the stakeholders, not actually the affected people, but the stakeholders, they doesn't have a good understanding about those techniques and how they use the generative AI, or how they can use this augmented reality, those things in case of disaster management. So we are in the process of implementing kind of open platform, where these analytics have been simplified. So we are working with the Mr. Supun and the GIS team, and some Asian Disaster Preparedness Center, Thailand, with this World Bank project. So we are in the process of establishing land-side analytical resilience advisory system. So in that case, on behalf of the communities, on behalf of the stakeholders, we have done major part of this technical analysis and all those things in our backends. So there will be some kind of simplified interfaces where the community or the stakeholders can do very simple the interactions and get some the process data get out. So that means that the complex analysis we have simplified with not all. So that's we cannot say that almost all the required analysis will be done there, but the most common some kind of basic analysis uh, we are trying to do. Because of that, the transform these technologies into the, the the communities or the stakeholders is very important. So there is the technology is there, but bridging them into the required people at the required time is very important. So we are working on that one. Hope we'll be able to deliver some kind of good output to serve the communities.
Right. Thank you, Dr. Chandra. Now I think it's reminding us that the important thing is not about the model accuracy, but how many lives we have saved, right? Ms. Preetika?
Yeah, I think risk mapping with all the agencies together, then we can focus local community, at least identify vulnerable areas for the disaster resilience purpose. We call under WMO interoperability, collaborate with all the agencies, work for the people. That's my comment.
Thank you, Ms. Preetika. I think so. You have highlighted about this methodology and also how it meets with the governance, right? So, Mr. Supam?
Yeah, actually, for this collaboration, the technological platforms are already there. The software is capable of doing that. I think already using that, I have seen this Ditwa landslide locations all shared by NBRO through that enterprise platform. So I have seen many agencies using that. So they are already doing that. So that platform is already there. So whatever the policies and the workflows we need to refine further, then I think, and also from the students' end, I would like to see, so they have learned these technologies, but think about the applications. Maybe those applications in your village level, right? Don't think about the highest level. So when we take your research also, we always see land surface temperature, landslide vulnerabilities. So you all think about the large scale and the, the very popular topics. Try to take certain topics in your granular level, or maybe the ground level, right? You will find certain very important things which is very useful for these agencies also. Then you can collaborate and contribute to these agencies, and also the technology side we can support you. So that's, and also this platform is very good for continuing that process.
Thank you, Mr. Sukun. So thank you very much for highlighting that sustainability aspect and also the R&D, the research and development aspect too. So before we wind up the session, Dr. Nabil, do we have enough time to have 2 or 3 questions from the audience? Right. Thank you very much. So since Dr. Nabil agree with us, so we can open the floor for maybe 2 questions. So anyone from the audience, if you have any questions or anything need to clarify from our esteemed panel, now the floor is yours.
Thank you. That's a wonderful uh, discussion that we had, and good exposure to the subject matter. Well, I'm Major General Mano Pereira. I have about 34 years of experience in the Army. And then my initial exposure to disaster response was in 1978 when I was a student. Since then, I've been involved in a lot of national level response programs, and also I have hands-on experience. So what Professor Fernando was saying, how the community feels is far from what we are talking today. They don't have this access to technology. And even if they have, if the technology is interpreted in a wrong manner at grassroots level, the damage is going to be much more severe. So, and also, as he said, very correctly pointed out, this affiliation to symbolize it, or symbols or your belongings to that community plays a very vital role in developing resilience. I know NBRO has been doing the hazard mapping from a long time. I was in charge of the entire Central Hills from Central Province, all those areas under me at one time, and all the maps have been given. But yet, when it comes to the critical requirement, nothing is implemented. They're ignored over a period of time. The complacency sets in and say, okay, this has been warned, but nothing has happened. And then you go into your what you call previous experiences, the experience that have been passed down through generations, and say, no, this will not happen. So what we have to do right now with the young generation is to take it up and spread it to those people who are required, so that we get a better response. And I also should say, since I've been involved in disaster response for a long period of time, we have come a long way from where we were. Casualty rates have been decreased, but still, there's one vital factor that I want to point out: interagency cooperation. That is still far behind. Sharing of information, we always say, yes, we share the data. No, it doesn't happen. This is facts. These are facts. I have tried to develop models, and with the with the assistance of private entities, exactly what Dr. Tisir was talking about, it doesn't happen. They don't cooperate. You ask for data, they say no. You pay and take the data. This model is ours. We are not going to give. That is the very reason why we are here today, why we are at this level today. Even Ditwa, I was involved in Kotmale and all these areas. NBRO has given sufficient warnings, but it was not delivered to the grassroots level. That is why the people got caught. And then still, some of them have not been, I mean, it's sad to say, their grievances have not been addressed. Some of them are still in those broken houses. They have no place to go. And they are saying, okay, we have not been given an area, we have not been told what to do. But then, as Professor Fernando said, there is a sense of belonging to them. They don't want to move away from that area. They say, we have been living, generations have been living, so where are we going to go? So these are critical questions that need to be addressed, which has to be addressed at a little higher level. And of course, the young generation, like what they did for Ditwa, we have to develop different platforms which can deliver the message to the grassroots levels. GIS has been has been in this country for more than 20 years. Most of the agencies are unaware of the use of GIS. There are qualified people, including in DMC, but nothing is being used. I mean, these are facts. So we have to encourage greater usage of these technologies and information and knowledge so that we could reach a better level of disaster resilience in the future. That's my comment. Thank you.
Thank you very much for the compliment. Actually, thank you again. And we can have, I think, one more question from the audience. Anyone would like to ask any question from the panel?
So thank you, General Manopera, sir. You're sharing your experience. And we have flood with lot of technological things and patterns and all things. What the end comment is, the organizations are not helping each other. So I think you have called upon one of the great resources here, the social scientists. So my question is like this. All the organization who we are sitting here, we have a ego. That's a problem. So General Manopera has developed a model. So, I mean, not like you are doing that one, but if you have developed that model and you have developed the data, you're not going to sharing it with somebody sometimes. So we do like that. That's the ego we have. So as a social scientist, I am asking from the professor how we can manage this our ego first. So that's my simple question.
I think it's a socio-psychological question. Professor Sagar is the most suitable person to answer that question because I am a sociologist, but Sagar has done his PhD on psychology. But I admit the fact that, yeah, but I just want to post Sagar can just answer. I just want to post a question now as uh, General Manopera said. Now, just think about this. We had tsunami in 2004, and we have been working on early warning, evacuation, critical infrastructure, resettlement, relocation for the last 20 years. 2015, 2017, we had another flood and landslide disaster. And NBRO has a lot of experience on relocating people since then. But still, even after Ditwa, we are struggling to come up with a reconstruction model. Right? So we have gone back to point zero, right? Because we have a lot of experienced people and we have a lot of published literature. It's a matter of just exploring them and coming up with a kind of a model, right? So I don't know where is the gap, but it's up to you to decide what was the not was not what was the problem, not the issue. Sagar, over to you. I think you can clearly answer. Oh, yeah, no, it's
Okay. Yeah, thank you very much. I also agree with you. Actually, I mean that ego is there, but I think when it comes to national level, I mean that if you have data set, you don't, though you are having such kind of ego, if you have kind of authentication or the authority given to share that data, I don't think that you can keep the data. For example, RMBO. So if you are asked to share your data with the other organization in written, you will have to do it. It's though that it's yours. I mean that though that you develop that data, I don't think that, because that is not personal, right? It's not personal, because I mean that you are working for a institution. So then if you are asked to share your data set with the other related organization, you are bound by the rules and regulations, right? So therefore, I think that we'll have to strengthen the rules and regulation, not just, I mean that trying to build up their, psychological capacities and so on. So that's my comment actually. I mean that that is the issue, that we are not having very good, coordination among, institutions. So if we have a kind of rules and regulation where you need to coordinate and with whom you need to share the data. So if you are given, I mean that, the rules and regulations, so then that won't be an issue actually. For example, even though Mano Pereira developed that, but you will have to give it, because that is not for your I mean that benefits. That is for a institution, because personally we don't develop that. That's institutional, I think. Thank you.
Thank you, Professor Sagar, and thank you, Professor Fernando, for highlighting and ignite the panel about this institutional collaboration aspect. But I think we can discuss it further during our tea break as well. So I think we are coming to the end of our panel discussion. So what I understand from here with this esteemed panel is GeoAI gives you new eyes. So we can see these things with some sophisticated and modern technology. But seeing is something beyond acting. So when it comes to acting, we need this kind of a collaboration to go forward. So that's the idea behind using these modern technologies when it comes to disaster resilience. Even for the other technologies, it applies as well. So I would like to thank our four panelists, Professor Nishara Fernando, Dr. Danuska Jayatilaka, and Ms. Preetika Jayakudi, and Mr. Supun Sirivardhana for your valuable participation and providing some valuable insights into our question and inspiring about the possibilities. And thank you very much again. I think we should give them a huge applause for that kind of idea. Right. And thank you for the everyone who has joined us today. So this conversation not going to be ended. I know it pretty much sure. So it continues in the hallways, maybe during the tea breaks, and maybe in the field station, and maybe during the discussions in their meetings in their respective departments and institute. So let it be continued. And at one point, let's see, the disaster resilience will come to a point that there will be no such issues again. All the institutes will provide their full capacities to save the lives of our community. So that's the end idea I would like to highlight from this panel discussion. So that's going to be the end of this panel discussion. Over to you, Loretta.
Thank you very much, sir, for steering that discussion with such clarity and depth. What we heard this morning across sociology, meteorology, geotechnical science, and geospatial technology truly reflects the interdisciplinary spirit at the heart of this project. May I now respectfully invite Professor Farina Ruzek, Head of the Department of Geography, University of Colombo, to kindly appreciation to our distinguished panelists and moderator. Our first token of appreciation goes to Professor Nishara Fernando, whose 26 years of scholarship in disaster studies and social vulnerability has given us a powerful human lens through which to understand what GeoAI ultimately serves people and communities. Professor Nishara Fernando, on behalf of the GeoAI for Disaster Resilience Project, please accept this token of appreciation. Our second token goes to Dr. Danushka Jayatilaka. Dr. Danushka, with sincere appreciation, please accept this token of gratitude. Our third token is for Ms. Pritika Madhavi Jayakodi. Ms. Pritika, with sincere thanks, please accept this token of appreciation. Our fourth token goes to Mr. Supun Sirivardhana. Mr. Supun, please accept this token with our heartfelt thanks. And finally, a token of appreciation for our moderator, Dr. Tisara Geetika Pereira. Dr. Tisara, for your guidance this morning was exceptional. Please accept this as a token of our appreciation. Thank you, madam. We will now take a short tea break. Refreshments are available just outside this hall. Please enjoy. We kindly ask that you return to your seats by 11, as we will be moving straight into the project evaluation and way forward session with Dr. Novil Wijayasekara. Thank you. See you back here at sharp 11.